In this video, we're going to talk about special products as they relate to factoring. We're going to focus on two of them. The first one is called perfect square trinomials. It does have a formula, which I want to go ahead and give you. Something in the form a squared plus 2ab plus b squared can be factored into a plus b squared. Now that's nice. But I want to note something, and that is because we're talking about a trinomial, and hopefully you see this first example here, that's something that we know how to factor using the x method. And in fact, I'm going to use the x method to factor rather than actually try to work this formula out. So note, we can factor using the x method. And my theory is, why learn a new method when I already have a method that works, that I've been practicing and I understand? That way, on an exam, I'm not trying to tell the difference between this problem and the ones I've been doing before. I can use the same method on all of them. So let's try. Let's see how the method works. And I'll also give you an opportunity to see that how we know this is a perfect square trinomial using the x method. Okay, so let's go ahead and we're going to approach it like we would with anything with the X method. I am going to check and see if there's a GCF. And there isn't because 2 goes into 4, but 2 doesn't go into 9. So there's no GCF on this. So I'm just going to multiply the 4 and the 9, which gives me a positive 36. And then I'm going to write the negative 12, the middle term there, at the bottom of the X. Okay, so two numbers that multiply to be positive 36 but add to be negative 12, that's negative 6 and negative 6. Both negative. That way they multiply to be a positive but add up to be the negative. Okay, so I'm going to rewrite this as 4x squared. And instead of negative 12, I'm going to use this negative 6 and negative 6. Negative 6x, and then bring down that plus 9. Okay, so now that I have 4 terms, I'm going to factor by grouping. Out of the first group, I can factor out a 2 and an x, and I'm left with 2x minus 3. Out of the second group, I'm going to factor out a negative and a 3, and I'm left with 2x minus 3. So the blob is 2x minus 3, and then I'm left with 2x minus 3 here on the outside also. And since it's the same thing, I could actually write that as 2x minus 3 squared. All right. Now, I actually don't care which way you write your answer. If you want to just write it as 2x minus 3 times 2x minus 3, that's fine. You don't have to write it like this, but you can. You could write it either way. And if you want, it's okay also to skip to writing it like this if you want to write it with the squared. There's nothing wrong with that. Both answers are acceptable. I did want to make a note though. The fact that it was the same number twice is actually telling me that this is going to come out to a perfect square trinomial. So when we end up having the same number that works for multiplying to be the top number and adding to be the bottom number, we're working with a perfect square trinomial. So that's kind of a nice piece of information to help me out. Okay, so let's go ahead and look at this next one here. Same setup. Oops. I'm going to go ahead and see if I can factor anything out. So let's see. 5 doesn't go into 4. Okay, so no, can't factor anything out. It's kind of a weird x. Okay, so let's go ahead and figure out what goes at the top of the x. So that'll be 25 times 4, which is 100. And then at the bottom of the x will be 20. So two numbers that multiply to be 100 but add to be 20. That's 10 and 10. So again, same number twice. So I'm already knowing that this is going to factor out into a perfect square. Okay, so that's going to be 10x plus 10x plus 4. All right. Oops. Let's factor by grouping. Oops. Being a little sloppy here. Okay, so out of the first group, I could factor out 5x and I'm left with 5x plus 2. Second group, I could factor out a 2, and I'm left with 5x plus 2. So I have 5x plus 2 for my blob times 5x plus 2, or I could just write that as 5x plus 2 squared. All right. Now here's where it might be useful to know that something's a perfect square trinomial. So I go to multiply this one, and I'm going to actually have to grab my calculator for this one. So I do know that 49, that's divisible by 7, and I know 7 doesn't go into 64. So this doesn't have a GCF, and I kind of wish it had because 49 times 64 is a pretty big number. It's 3,136. All right. So I'm looking for two numbers that multiply to be 3,136, but add to be 112. Okay, so here's what I want to do. I want to kind of notice or wonder, is this possibly a perfect square trinomial? So here's the first tip off that it could be a perfect square trinomial. If the very first number and last number happen to be perfect squares, it might be a perfect square trinomial. Does not have to be, but it might be a perfect square trinomial, which means if it is, then this is going to be the same number twice. In other words, I have to find a number that adds to 112, but multiplies to 3,136. So basically what I'm going to do on my calculator is I'm going to look at this 112 and I'm going to divide it by 2. And that gave me 56. And I want to see, is 56 times 56, does it give me 3,136? And it does. So my whole thought process was I was able to figure out this magic two numbers by kind of being suspicious that maybe it's a perfect square trinomial. Now, one more time, it isn't always a perfect square trinomial just because the first number is a perfect square and the last number is a perfect square. But it's useful when I have really big numbers like this, 3,136. That's kind of a tip off that it could be a perfect square trinomial. All right, so, I just realized that this was a negative 112, which means I need negative 56 and negative 56. So negative 56x, negative 56x plus 64. Okay, so here's what I'm factoring. So let's see, 7 does go into 56, and I can factor out an x. So that leaves me with 7x minus 8. Okay, second group, I could factor out 8, and I'm going to pull out a negative, so that'll be 7x minus 8. So 7x minus 8 times 7x minus 8, or 7x minus 8 squared. Okay, so that's when it can be useful to know that it is in fact a perfect square trinomial. Okay, second type of special product is something called a difference of squares. Now this one has a formula too. And even though we kind of use the formula to factor these, again, we don't really need to worry about memorizing it because a pattern kind of emerges. So here's the formula. If something is in the form of a squared minus b squared, it's going to factor into a minus b times a plus b. So let me show you what that looks like in actual working it out. So when I look at this first example here, I notice that my first term is something squared. It's x squared. But 9 is actually a perfect square because 3 squared is 9. So this is going to factor into x minus 3, x plus 3, where the 3 is coming from the fact that it's 9 squared, and the x is coming from the fact that it's x squared. I'm sorry, that 3 is 9 squared. I hope that made sense the way I said that. It's a little bit funny. Let's try that again. Okay, so we ask ourselves, are these perfect squares? Does something squared give me this number? So I look at the 36, and 36 is 6 squared, 6 times 6. 121, that's actually 11 squared. So this is going to factor into, oh, and I'm sorry, I noticed I also have a y and it's squared. Okay, so everything really is a perfect square here. So this is going to factor into 6y minus 11, 6y plus 11. And that's it. That's the answer. Now, quick comment. The minus and plus, it doesn't really matter the order I write it in. I could have wrote plus 11 and then times negative 11. It's the same thing. The order does not matter at all. In fact, I'll switch it on the next one just so you know it doesn't matter. But what matters is that we got the 6 from the fact that that's where the 6 squared is 36, and the 11 came from the 121, and that we have opposite signs in the two parentheses. So one of them is negative and the other one is positive. Okay, so let's try another one. So 100 is a perfect square because 10 times 10 is 100. M is a perfect square as well. And 1 is a perfect square because 1 times 1 is 1. So this is going to factor into 10m, and here I'll switch it. It'll be a plus 1 this time. 10m minus 1. And that's it. And there's no short way to write this because they're two different terms, right? It's one's a plus and one's a minus. So I have to write it out like this. Like, unlike the last ones where I could write the square, I can't do that here. Okay, now quick comment. This only works if this is negative. That has to be a minus because this is a difference of squares. So it has to be a subtraction. Has to. If it's not, it doesn't factor. Okay. In fact, let's make a little note of that. Note a squared plus b squared can't factor. They call that prime, by the way, when it can't be factored. So be aware if there's a plus sign, they're tricking you. You might think, okay, so like if I saw x squared plus 16, I'm like, nope. Even though those are both perfect squares, that doesn't factor because it's got a plus sign. So the answer is this is prime. It's not, you're not able to actually factor it. Okay, so here, let's try a couple more. The only way it kind of gets interesting is if they maybe throw in a GCF. So I noticed 2 is not a perfect square, okay, and neither is 50. However, 2 does go into 50. So I could first factor out a GCF of 2, which would leave me with z squared minus 25. And this is a perfect square. The z squared is a perfect square. 25 is 5 squared. So this is going to factor into z plus 5, z minus 5. And then bring the 2 down in the answer. Don't forget the GCF in the final answer. All right, one more exciting one. So this one has a fourth, but it is a perfect square. Okay, it's a little bit weird, but x squared times x squared does equal x to the fourth. So we could think of this as x squared. Okay, and then 16 is 4 squared. Okay, 4 times 4 is 16. So x squared plus 4 times x squared minus 4. But this isn't done. And the reason is this is another difference of squares. I'm going to abbreviate that. It's another difference of squares. So it can actually factor again. So it can factor into x minus 2 times x plus 2. But this one is not a difference of squares. So we just need to bring it down into the final answer. So it's just going to stay out in the front, x squared plus 4. But the x squared minus 4, that factors again. And then this would be our final answer. And that's really as tricky as they get. If this had happened to be like an x to the 6th, I'll just kind of write it over here. If this happened to be x to the 6th minus 16, then that would have factored into x cubed minus 4, x cubed plus 4, and that wouldn't factor again. That would be the final answer because um, x cubed is not a perfect square. So that would be it. And I hope you notice that I'm kind of just having the exponent, right? That's where the 3 is coming from. I'm taking 6 and I'm dividing it by 2. I'm just halving it. So that's how we're kind of thinking of that as a perfect square by literally dividing the exponent by 2.